on the earth we have air resources, and the atmosphere is a massive resource for us as humans. How did we originally get the atmosphere that is here now? Well, billions of years ago, the smallest microorganisms started respirating, and they basically were able to use whatever chemicals were available to them in the air. um, they were able to find a way to grow and breathe, and over time some of those organisms were able to breathe out oxygen and use sunlight, which was readily available, to basically start the process of photosynthesizing. And that process of photosynthesizing and breathing in like CO2 and giving off oxygen was something that made it possible for other organisms that breathe in oxygen to inhabit this earth. And so, oxygen is something that's really lightweight. It actually does float, but but it does have some weight. It's not weightless. And our gravity that we have here on Earth will actually hold a lot of our air to the earth. So the gravity that we have is actually holding our atmosphere in. And without that gravity, a lot of that air would just get lost into space. So there's not an actual like plastic wrap bubble that's holding it all in. It's really held to the earth by gravity. So this is a kind of like a graph that over time it's showing how different organisms were able to create our current very oxygen rich comparatively environment here on the earth. So different different nutrients will cycle through the earth through different spheres. So you have like the hydrosphere that has water, you have the geosphere that has the land, you have the atmosphere that has the sky, you have the biosphere that has living things, and you can see those here. So these different nutrients will cycle through. Well, there's two that we're going to talk about here that are really instrumental, that are key for having life on Earth. And one is carbon. Carbon is very important because it exists in every living thing. So it's a key element that we need. So, because this is a carbon cycle and this one is a nitrogen cycle, in a cycle you can start anywhere like on the chart, like it doesn't matter, but we'll start up in the air. So if you have carbon up in the air, how does it get down into the biosphere, into the geosphere, into the hydrosphere? Well, it can get there like several different ways. It can come down, and you can see the arrows that are pointing down is how it gets down from the sky. It can do that through like plants in photosynthesis. They will breathe in CO2, which is carbon combined with oxygen. You can also have the ocean is a giant, what it's called, carbon sink, meaning it absorbs a lot of carbon in it naturally. This actually slightly acidifies the ocean. So we have to be careful, like environmentally, that yeah, we're producing more carbon dioxide that affects the air, but it's the ocean is actually absorbing a lot more, which makes it a lot more acidic. Well, just actually not a lot. It just makes it a slightly more acidic. And big things don't really die when it's like 0.1 more acidic. It doesn't really bother the big things very much. What it bothers is the little things, and the little things die off. And because the little things feed the bigger things and they feed the bigger things in the ecosystem, that's why this is important. Um, so at any rate, there's different ways that carbon can also be like trapped in or move from one of these spheres. So if you have dead and decaying matter from the biosphere, it can die and decompose, turn into oil, for example. You can have some turn into coals, some turn into natural gas. Those are then mined sometimes and brought up and used, in factories, in cars, in all kinds of different ways, and then it returns to the atmosphere. So this is one cycle. Okay. And another cycle is the nitrogen cycle. So again, it's a cycle. You can start anywhere. We're just going to start in the air, not hydro, in the atmosphere. And so from the atmosphere, you can have it fixed by various bacteria. This is actually one of the most important parts of this cycle. Nitrogen fixing is bacteria that take nitrogen and convert it into a form that plants can use, and then we often eat the plants or use the plants. But without nitrogen fixing bacteria, we would not have the nitrogen, I apologize, that we need to survive. And nitrogen makes up proteins in our bodies, and proteins are really in all parts of your body. So this is a hugely important process. We are very dependent on nitrogen fixing bacteria, and we need them to stay really healthy in the soils. So from the atmosphere, you can also have it rain and have nitrogen come down in that way. It can cycle all the way through the hydrosphere, and you can have different pollutants and like acid rain and things like that bring down nitrogen. So there's a lot to this process, but you guys just need to know the basics for this chapter. Okay, so I talked a little bit about pollution, and pollution in the air. One of the reasons why I've noticed that people say it smells so clean or so fresh or the air is so crisp after a rain, and we don't get that very often in California, is we actually do have a lot that goes up as far as cars and things like that that release a lot of pollutants, and we breathe it for a little while. But then after a rain, the rain actually will bring those pollutants down, and it does hit our cars and statues and buildings, and it can erode those things as acid rain. It also goes in the waterways and the soils. So we want as few of those pollutants as possible, but that is one of the reasons why after rain people say, oh, it's so fresh and clean. It's because a lot of those pollutants have come down. Pollutants can actually travel a great distance. One example from your text is that Mount St. Helens erupted in the United States. Mount St. Helens is on the west coast in like Washington, and 3 days later on the east coast, um, according to your book, they were already collecting ash from the air on the east coast. So these air and wind streams travel great distances. We talked about jet streams, global jet streams earlier, a few chapters ago. But they are critical. I have noticed too, when I did work in the Great Barrier Reef, their country, for a first world country, is fairly environmental. On the consumption list that we saw in two sections ago earlier in this chapter, we're in the United States spending about $15,000 per person. They're more like 7,500 to 15,000. So they're like a step less, one step less, but that's better. And so I noticed that they were so environmental, yet they're having these problems where nearby countries are doing a lot of manufacturing, a lot of factories and that kind of thing, and the air just travels and gets trapped right there over Australia and the Great Barrier Reef. And so they're seeing problems that way. Other pollutants can be carried by fires, and one that's really important for your homes is that radon gas, which it's colorless, it's odorless, it's tasteless, and it's naturally occurring in rock. Radon gas will slowly be given off from the rocks and concrete that are used to construct your house. In um, small amounts, it's harmless to you, but out of the 21,000 people that die each year from lung cancer, about 2,900 of those people have never even smoked at all. And some of that can be from chemicals that are being given off, like radon gas, from your home. Because of that, and for other reasons, homes are not airtight. They are not sealed airtight, and it's also very hard to make a home airtight. But the all of the air in your home does cycle through a few times a day, and that's good for us because it gets that bad air from the building materials out, and will kind of cycle that through. And of course, it's always good to open your windows and have some fresh air, so that you're not breathing in things that are not healthy for you.